from BS Mathematics major in Business Applications 2B together with Clyde Michael David, Aliyah Dacumos, Chari Daliwan, and Sofia Sanchez presenting our topic entitled A Dual Series Mathematical Framework for Approximating Present Value and Finance Forecasting Using Taylor and Geometric Series. In the fast-paced world of business, every decision matters, from setting prices and maximizing profits to predicting market trends and minimizing costs. In this video, we'll explore two important series: the geometric series used in economic illustrations such as the time value of money and present value calculations, and the Taylor series applied in approximating and analyzing financial models. Our goal is to show how these mathematical concepts can be applied in the business world to make smarter and more effective decisions that will lead to a greater success.
Have you ever wondered how banks determine the value of your savings today, even if you'll only receive them years from now? Or how financial analysts can estimate future investments without knowing the exact exponential model? And finally, how traders predict option price changes without using complex financial software? These questions all have one thing in common: calculus. Let us begin with the geometric series, which is used to determine the present value of a series of future payments. Consider this example: receiving 20 peso at the end of each year for the next 20 years. And because of time value of money, the future 20 peso payment must be discounted using a rate R. The present value can be then represented as a geometric series. PV is equals to the summation of 1 plus r raised to negative n, where n runs from 1 up to 20 times 20. Applying the sum of a finite geometric series where L is equals to 1 over 1 plus r, while n is equals to 20, then substituting the values and with some simplification gives us PV is equals to 20 times quantity 1 minus 1 plus r raised to negative 20 all over r. Then, there are different discount rates imposed by the Bangko Sentral ng Pilipinas, and by substituting those, we can obtain at 5%, the present value is equals to 249.24, and at 10%, the present value is equals to 170.27 pesos. This demonstrates that the higher the discount rate, the lower the present value is, since money in the future holds less worth compared to money today. This application is essential in investment evaluation, loan assessments, and financial decision marketing. Now let us move to the Taylor and Maclaurin series, which allows us to approximate and forecast financial data when only partial or initial information is available. For example, consider the monthly revenue of Gada Tanning Salon modeled as 4.5 Euler raised to 0.04T, where KT is the revenue in million pesos and T represents months after the salon's launch. Since the company only has the data at t is equals to 0, they can apply the Maclaurin series expansion of Euler raised to x. We now take the known Maclaurin series of Euler raised to x, which is equals to x raised to n all over n factorial, where n runs from 0 up to infinity. Then, substituting x, which is equals to 0.04t, we will have this expansion. And when t is equals to 6, we will have this expansion and a final answer of 5.72 million pesos. However, in this example, the exponential model is known. Alternatively, if the exponential model is unknown, we can still use the Taylor series form, relying only on the initial value and its derivative at launch. If so, we will have this expansion where we use 0.18 as its first derivative and 0.072 as its second derivative, arriving at a final answer of 5.719 million pesos. Both results are nearly identical, demonstrating that Taylor and Maclaurin series can accurately estimate short-term revenue changes, even when the exact growth model is unavailable. Let us now consider another important application of the Taylor series in financial modeling, particularly in option pricing. The price of European call option depends on its volatility, denoted by sigma, which measures how much an asset's price fluctuates. At a known volatility of sigma sub 0, it is equal to 0.20, and the following values are given. While experts use the full Black-Scholes model to calculate option prices in the Philippine pesos, we will focus only on Taylor series, hence the derivatives are given. And using the second-ordered Taylor series expansion, we will have this expansion. Then, substituting the values, we will have a final answer of 10.98 pesos. Thus, the option price rises from 10.50 to 10.98 pesos as volatility increases slightly. In finance, this method is specifically useful for sensitivity analysis, helping traders and analysts to make informed, data-driven decisions in dynamic markets.
In conclusion, in geometric series, to determine the current value of future cash flows showing the time value of money. For example, the 20 Philippine peso bill at the end of each of the next 20 years. We use the present value approximation denoted by PV, calculating the exact future values. While the Taylor series, a critical tool in making informed strategic decisions and quick short-term forecasts for complex functions, is the financial forecast.